And I'm still dropping some, so I'm done. It ain't meant for me. It is not meant. Okay. All right. So today's agenda today, we are working on string functions, case statements, joins, and subqueries. So this is when we get into more or less and I am recording, good. This is where we get more or less into the more advanced functions of SQL. Also, make sure that with these, go back and just look at the video, go back and talk through things. Hit me up if you want to talk through them, because string functions are not that bad. Subqueries are not that bad. Case statements are not that bad, but joins, sometimes people have a hard time with conceptualizing it, myself included. I was a whole senior data analyst and was still like avoiding joins. However, the way that I explain it to you all is the way that I grasp it now. And that was the big gap that I was experiencing when trying to learn it. Like I try to explain it to y'all to eliminate that gap. So string functions, joins, subqueries, case statements. Those are the objectives for today. So let's get into string functions. So string functions are essentially functions within SQL, no different than like our aggregate functions, our window functions, once we get into those. But they're used to extract certain data. And they make that data useful for whatever your use case is. Let's say you're in a position to where you get data from a database that the data source is like user entry, meaning the data is captured off of a website, or the data is captured when people check out at the checkout counter and they put their name in, or whatever the case is, where that data is potentially non-consistent, or it requires a level of cleaning. That is when you would have to utilize window functions. I mean, string functions, I'm sorry. String functions go into like the data cleansing portion of your data analysis. And what they essentially do is they allow you to extract super useful information, but leave the rest. So what we're focusing on today, or at a high level, what we're going to focus on today is concat, upper, and lower. There are also multiple string functions like like. Those things allow you to extract data that matches like whatever your data set is. Like if I say select like and I put certain characters in there, it'll bring me whatever I need that matches that. With concat, you all have probably seen something similar with concat, probably in Excel. Excel uses concat a lot, and essentially what that does is it allows for you to combine two different fields or columns. Let's say you're in a position to where, like this example here, let's say you're in a position where you need to combine two different fields into one column. You would say select concat, this is your function. Open up your parentheses the same way you do with your with your aggregate function. Open up your parentheses and literally put your column names here. Close it up. As, this is your alias, full name, because you're going to give that column a new name. So in this use case here, we are concatenating the first name column and the last name column as full name. Also, think about it within like healthcare, where I've seen a lot of it is the fact that, let's say you have to generate some sort of ID or generic ID for a patient or a use case or a patient. A lot of times I've seen where they might take like the first four letters of like their last name and then two letters of like their birthday or whatever it is, and they'll concatenate them together to create like this unique ID. So in that event, you've probably seen things within your day-to-day work and don't really realize that it is the result of someone concatenating multiple fields together, whether they're breaking them down or what. So these are essentially string functions. Like I said, that's when you get into your data cleansing part of your analysis, because they allow you to really like extract just useful data. What do you need out of that column, and how? What do you need, and how can I present it in a way that it can be useful for my analysis? Because I might not need the full data. I only might need a few letters or a few, first four, whatever the case is. That's where those string functions allow you to apply to it. Remember also that a string is literally like the text. Remember when we're in our code and I'm like, you got to make it a string. You got to make it a string. It's referring to the text. So you're essentially saying functions of the text that's within the column. Any questions, y'all? Okay. So for this one, this is pretty easy. I'm going to get you all to, let me share my screen. Here I am. So remember, everybody's connected to the VM. This is our server. The server is the top dog. It's the brain. It houses everything. This is our server. These are our databases here. If it open up, when it does. These black things, these are databases. Go into your database, and these are your actual tables. It's not uncommon. There you go. It's not uncommon for you to have to jump between different databases, jump between different servers, even in your day-to-day work. So the way that we are going to do like these next few sessions, these next couple sessions are within the use cases. I will provide you the opportunity to do work within multiple servers. Like I'll say, okay, well, we're in healthcare system, or we're in data analytics simplified, or we are in what's the other one? Custom orders DB. Like I will give you the opportunity to kind of navigate, hey Stephanie, between each of those databases. So for this one, we are in, let's go within our healthcare system database. Stephanie, I was given the high-level overview of string functions and the purpose of those string functions regarding like data cleansing, data preparation. They essentially just allow you to extract like useful information from the actual data itself, from the actual columns of the data itself. So that's what this first objective is today, is string functions. So let me know, and let me share my screen with it.
Sorry, I'm late. I'm in the middle. My
it's okay.
Dad passed yesterday, so.
Oh my God! Why are you here? Bye.
Sorry to hear that.
Yes. Do you want to? Bye. I'll teach you. We'll talk one-on-one.
Okay. All right.
And I'm sorry for that, Stephanie.
Thank you.
Yeah, like go. We'll catch up.
Okay,
and
good. Thank you.
I'm so sorry for that. I'm so sorry for that.
Okay.
Yeah. Well, I'm about to cry. Okay, where was I? Okay, so go within your healthcare system database. And we are going to go within our healthcare system database first. These are our tables. So to start out, let's concatenate the first and the last name of your patient. Let's start with that. Let's do that first. I will bring up the use case here so y'all can see it on the screen. So the first thing you need to do, remember, data investigation. Let's do some data investigation to figure out which tables houses the actual data.
Lorita, I have a question. I don't know if I'm in the right. Can I share my screen with you really quickly just to make sure I'm in the right spot?
I'm on the wrong screen. There you go. Yep.
it's not letting me share. It's not letting me share. I'll try to figure out why it's not letting me share.
What error are you getting?
You can go back.
What error are you getting? Why you think think you're in the wrong spot?
Yeah, I mean, it doesn't. It looks a little different from what you have. I clicked on the data, the healthcare system database, and the database diagrams.
Don't go on database diagrams. That's the problem. Go under your. Let me pull mine over here so you can see. Go under your. Go under your tables.
Okay.
Not the database diagrams.
Okay. And then you said it was the prescription, Medicaid?
The patients.
The patient? Okay.
Yep, because I want you to concatenate the first name and the last name of your patient.
Okay.
Using this script.
So I clicked on, I expand the patients and then
update the, yep. Right click your patients table.
Okay.
And select your top.
Select the top 1,000.
Yep. And build your query. Get rid of this top 1,000 because remember the top 1,000 is the actual limit. I'm telling you to only bring the top 1,000 records. We ain't gonna do that. So just get rid of that and just update your syntax to capture the use case. Keep all the other columns there, but I just want the first and the last name concatenated together.
Okay. Thank you.
You're welcome. I'm gonna work on it too with y'all. Okay. I still don't have a sound. If you can hear me, like put a comment or something. Can y'all hear me? Can y'all hear me? Can y'all hear me? Yes or no? Can y'all hear me? How y'all coming along?
I'm not sure.
Let me see.
See how it. Hold on. Share.
I'm gonna stop sharing. Okay, so that's correct. Now, why you think you don't get? Why you think that's not right?
When you do the select top 1,000, like I had all of them up there, but I was trying to cancel out some of them, and I just got confused, so I just removed all of the columns that could have been there.
Yeah.
And then you see my cursor.
Yeah.
Right here. All right. So those two little
okay.
The two little exclamation points or
quote. Yeah. What is it? Quote. Yeah.
The single quotes. Right. I took both of them out because they weren't working at first. I had two of them like this. Like, what did they look like? They were red.
Yeah.
So I'm like, I don't know. I have a habit of playing around with this.
No, that's what you're supposed to do. That's what you're supposed to do. So let me explain what those single quotes are. I mean, those that essentially is an empty string. It's empty.
Right.
So you put quote, and then you have to put another comma because each column, quote unquote, you have to treat it separately. So put your two quotes there.
Put them there.
Yep. Now put your comma. Yep. Now execute.
Oh, let's see.
Put a space. Put an actual space.
It wasn't gonna work.
Put an actual space between it, like literally a space.
A space.
Yep.
Oh, so.
No, in between it. Yep.
In between.
Yep. Now execute. Perfect.
Oh wow.
Okay.
So it's okay to keep that empty right there. Is that considered a space in between the single quotes?
Yes. And the reason why that is okay is because of the concat function. When you say concat, I'm telling you to literally pull these columns together. Now, without that concat, it wouldn't work. But the fact that you have that concat function there, it changes the game because you're telling the system to concat this, bring this together.
It's a one column now.
Yes.
Okay.
Yes.
That's like at work, they do that. Like with me, it'll be Lisa, it'll be Lee Rob or something like that.
Yes.
That'll be my username.
Yep.
Yeah. Okay.
And that's probably the way that their data is constructed. They're probably doing a trim or whatever from like the first two characters from your first name, the first three characters, and they have a concatenating function to bring them together and you get your username. That's exactly what that is.
Okay. I understand. I do understand this. Okay.
Yep.
Thank you.
We use it so often, or we see the data so often that we don't think of like what goes on behind it to like make it like that. But yep, that's exactly what that is. Cause I have my username is like L Shaw, whatever. But
right.
It's like even when you go to the hospital and you got your bracelet with the MRN or whatever, they might have like your name, but then like a few digits. That's like portions of like I think I've been before. And it's been like a couple like on my birthday or whatever. It's like this is a unique identifier, but it's extracted. Like they're extracting the data from somewhere.
Yep. That makes sense.
Yep.
Okay.
And then they're concatenating it into one column. They're concatenating into the MRN, whatever the user ID or whatever it is, LS, whatever your birth, whatever. And you see it or consume it as a unique identifier, but it's literally code to pull it together like that.
Right. Okay.
Yep.
Yeah.
Yep. But I like when you're able, because to me, where the gap always is, like, for me, the way that I learn, because I'm not traditional computer science either. The way that I learn is like what you just described. Like, what do I see every day that is the result of this? And it helps you like make sense of it. So it takes it from like this code to like, oh, that's what that is. So that is concat.
Okay, I'll stop sharing this.
Oh, I'm
so
not.
This is correct then, right?
Huh?
this is basically correct.
That's 100% correct.
Would you ever get like use cases where you have concat and then also something else that would come before that? Like they want to concat in the middle of a use statement. Say they pull in for other things.
Yeah.
Okay.
Yep. Okay, so think of it like this. Everything that like you're learning is like, okay, think about you got this pot and you cooking like this stew or whatever. Everything we're learning is different ingredients that you can put together to make this stew. They still build on each other.
Right.
So,
right. But my question is sometimes like when I'm looking at things, I wasn't sure like what would come first. Like let's say for instance with the concat, would that come before or after? Like depending on what the use case is asking for.
It will always come. I'm still showing. I'm gonna use your. As a matter of fact, I'm gonna share my screen. Hold on.
I'm gonna stop sharing mine then.
Okay. Oh, wrong screen. Okay. Now you see mine. I kept all of my columns there, but
oh, you kept it. See, I was confused with that. I was like, let me get rid of all of it.
You can keep it, and if you want to get rid of it, just get rid of it like that, and it'll get rid of it all day long.
Okay.
But the way that your format will always be, you're always going to select whatever your columns are from this table, but you already know that. But where concat comes in is you literally treat concat like a column. So the same way you got these columns listed out, you have to list out concat, which is the function. Open up your parentheses, put in what you want to concatenate, close it up, and you say as whatever you want to call it, as whatever your column name is. This is called an alias.
I see it now.
Yep.
Because at first it was like patient ID, first name, last name, DOB,
yep.
gender.
Yep.
What you did was you combined first name, last name with a space inside of the parentheses, so it's all one.
Yeah.
I see it now.
Yep.
Okay. That's why I was getting confused. I was like, wait a minute, how am I going to drag these two together? But it's the parentheses that's holding them.
Yep. Think about it when we did our aggregate functions last week. So we got our aggregate functions and we say the average. We say AVG, open up our parentheses, whatever column that you want to apply the aggregate function to, you put it right in them parentheses.
Okay.
Let me pull it up so you can see it. And that way, once you get in the habit of that's the way those functions work.
So would it be a use case ever that you have concat also with an average?
You can, but it will be two different columns. Like, let me share my screen. Let me share my, okay. So this is our average function syntax. Remember, we got our select all day long. Sum is the function because it's pink, the same way our concat is. Then whatever we're performing our function on, we put it right in them parentheses. Concat is a function. So we say concat, but perform this function on this column. So it's the same syntax. Select our function, and then we open up our parentheses and put our column in there.
So it can't be two selects.
No.
Like select some and then, no, you can't do that.
What you can do is have it split up within each column, like commas. Select the sum of this and then go down to and concat this. Because they can be two different columns all day long.
That was my question. Like select sum and then comma. Would the comma go after that purchase amount, like after that last parenthesis, and then you'll do concat right after?
Yep. Now, that'll be two different columns.
Right. It has to be two different columns.
Yep.
It can't be the same at the I'll get it.
Yep. They can't coexist. But they can be within the same, block syntax with your blocker code. But they got to be distinctively separated. Think about it like this, related back to your natural language. In English, we learn when we list things in a series, we put them commas. I want this and this and this and this. Your code is the same way. Whatever we're listing out, it has to be distinctively separated by those commas.
And you don't have to add and or anything like that in between it. It could just be the comma.
Yep. Where you add and is when you get into the logical operators. Let's say down here, from this table, where you say where this column equals this. And
okay.
That column.
Yep. That's where the and will come in after the where.
Yep.
Okay.
Yep. That where and is a logical operator. Basically, and is used to filter. So that if I'm filtering data, I gotta have my data first. So it's gonna always come after from. From this table, where this column, and this column, and that, you know, and you put as many as you want, but they always gotta come after from. Always.
Okay.
Always. Uh-oh. You feel okay about that now? Good.
Yeah.
Good. I like those questions because it helps me like, oh, logical operators up here right now. Now look, the logical operator where this column, when and it, yeah, where this column equals this and this equals that. Your and always got to come out the from.
Because I think I was like trying my own, like I don't know what I was doing at first because I was so confused. I got it right eventually.
Right.
But I was playing around with it. I'm like, well, let me do select this and things weren't working out. I'm like, what am I doing wrong?
Think about it like this. Think about if, okay, so and is essentially a logical operator, which is a filter. We ain't doing nothing but filtering. In order for me to filter something, I gotta have it first. When you making your coffee and you put your coffee filter on there, your coffee is already in your filter. This is what's being filtered out, and this, and that, but your coffee already exists. That's what that is.
Thank you. I was like that. I think that was my biggest. Like I was like putting and in the wrong place. I'm like, wait, what goes first, second? Like I just didn't understand that part.
Yep.
Okay. So that's a logical operator that comes after where and from and everything. Like
yes.
Filter.
Yes. I can't filter nothing that I don't have.
Right.
Like when you think about your net, I can't filter anything that if I do not have my data set, which is what is happening in my select statement. In my select statement, I'm giving you the data I want. I want this column and that column and this column. From, I'm telling you where to get it from. Then I get into my filtering where this equals this and this equals this. But I already got my data. This gonna give me my data all day long. Filtering go always come after. I also think where you might have gotten confused as well is in our natural language, we list out comma, 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 but we also say in our last we'd be like, and this, like, it's just how, you know, and I think that might have caused you some confusion as well.
Because I was trying to pull like two columns with the word and.
Yep.
So it wasn't.
Yep.
Okay. Thank you.
You're welcome. But just always think, I can't filter it if I don't have it. I got to get it first. Once I get it, I can filter it all day long.
Can I share my screen, please? I'm still not able to get this. Still not able to execute it.
Share your screen. Okay, so let's talk about this. What is that star doing on line 1?
I don't need it.
Thank you. Why don't you need it? Because if I say select star, what am I telling the system to do? Keep that concat. But if I say select star, I'm telling the system pull all the data. So that star, a star cannot coexist with like you listing out your columns. It either got to be a star or your columns. So let's see where okay. Now the second thing is on line 1, you have it correct. Your problem is you close your parentheses after first name. You need to get rid of that one.
Get rid of this?
Yep. And you need to put your bracket in front of last name. Because the reason being is you already have your bracket, so you just want it to be consistent. Now put your what is it? A square bracket in front of, like how it is there. There you go. Okay. Yep. Also, one more thing, you are missing your comma between your empty string. Put your comma after your empty string. Because we are listing this, comma, this, and this comma. So put your comma in front of last name.
In front of last name.
Okay. Yep. Okay, perfect. Now execute. Okay.
Okay.
Star cannot exist with listing columns. You either pull in the columns because the columns are telling you what I want in my data set, or you pull in a star. So if I say select star, I don't need to list no columns.
Okay.
That was it. Now, and then the other thing was essentially just the way that your parentheses and stuff was. Think about when we doing our functions, we're always have our function, open up our parentheses, whatever columns that we want that whatever columns we want impacted by that function, we put in those parentheses.
Okay.
Yep.
Thank you.
You're welcome. Did they answer your question?
Yes, thank you.
Any other questions on CONCAT? Okay. Okay. So the next line of business are subqueries. So subqueries fall into what is called like that advanced filtering. We just talked about filtering a minute ago. Subqueries fall into that advanced filtering portion of your analysis. And what the subquery does is it essentially uses the output of one query to calculate another query. It's not uncommon where people refer to subqueries as nested queries because it's literally a query inside of a query. That is essentially advanced filtering. Now, look at this code here. Look at this logic here. What do you all think, just at a high level, what do you all think that this is doing? And break it down by piece by piece.
It looks like it's basically selecting the columns from the employees menu database. Mm-hmm. But it looks like it has an average already set in there, maybe. Then it's just once is that greater or lesser than, they want the greater than salary than the average.
Yes, ma'am. Okay. Yes, ma'am. Yes, ma'am. Now let's break it down even further. Now, this here, our aggregate function all day long. You called it out perfectly. Here, we are selecting average salary. We got an average, that's our function. Salary on this column from this table, period. Select the average salary from employees. That's all I want you to do. Now, this syntax selecting employee ID, employee name, salary, from the employees table where this the condition where this column is greater than the average salary. So I'm essentially saying select the employee ID, employee name, and salary from the employees table where the salary is greater than average. Now, when I do my subqueries, this part calculates first. This is your first part. This is where your filter comes in, and it uses this as the filter, where salary is greater than average.
So the where part is not really it's not really like calculating anything.
Right.
Is it already there?
Right.
You're on mute, Lorita.
Oh, right. We're saying where. That's our condition. That's our condition. Where this column is greater than. I ain't calculating nothing here. This is my calculation. This is my filter.
Okay. It looks like it's the same thing above in the where. We just dragged another one in there, really.
Yep.
Select cat.
2 queries.
2.
Yep.
Right.
A subquery is literally a query inside of a query.
That makes sense.
Yep.
It's like this. Right. I get it.
Yep.
Okay.
We use this logic as a condition. This is our condition. Where salary is greater than select 30. This is our condition. We're using this as a condition.
Is no easier way to pull that information rather than just making another it's almost like making a calculation against it.
Mm-hmm. And the reason being is because what this is asking, this is not just asking what's the average salary. Because if we asked what the average salary was, we got this all day long with this here.
Mm-hmm.
The ask is who's making greater than average? What's greater than average? What employee is making greater than what the average salary is? That's where this type of logic comes into play. How many people spent this amount of money last year? Or what was the average amount, and who spent greater than that? Because they're considered our, high spending customers. Or even in healthcare, let's say if the average like rate of like cholesterol or whatever is supposed to be this, who is greater than that? Because that means that they're at risk. What's another use case in another industry? Crime rate. The average violent crime for this particular county or city is this. This particular county or city is higher than average of crime rate. All type of ways. What's the average time that people spend within this facility, within this unit, within this whatever? And who is spending more over the average? What's the time? What's it? Length of stay? Those type of things. What's the time of this? What's the time of it? All that type of stuff is this type of calculations. Yep. Any questions?
Is there any instance where you just have to pull one employee rather than the whole list?
You talking about like from your select statement?
Right.
You would say, where salary is whatever, and employee ID equals 236, whatever. That's where you would get into your logical operators to filter down who you need.
Okay.
Absolutely.
It would be like and.
Yep.
The salary, average, and the employee.
Yep.
But I have to make an assumption based on what with the employees. I'm gonna have to make like an assumption, right?
What
like say the person makes like $10,000.
Mm-hmm.
Would I have to make an assumption, like if it's less than or greater than 10,000, just to pinpoint it?
I don't know what you're asking.
Like when they ask you, because when they ask you just for one employee,
Right?
rather than a whole bunch of them.
Do you?
And you don't know who that employee is. You know what I'm saying? You don't know.
Oh, well, that's when you can search it by name, where first name equals or first name like Like. That's another string function where first name or whatever last name, whatever those columns you're using to identify, that's when you can use a particular string function called like. You would say where first name like.
Okay.
This.
I get that one. All right.
And then it's like you open it up and you type like, let's say the first 3 or 4 letters of their name. Because it's like they spell it differently or something. Where first name like this and last name like this or equals to or whatever the case is. And that's where you would like kind of build upon it like that.
Okay.
Did that answer your question?
Yep.
Yep. It's essentially that part is a filter for sure. But it's also a string function too, a form of a string function. Because with that string function, we're able to extract exactly what we need. Based on the information we have, we might not know how to spell their full name. But if we can put like the first 3 letters, it'll bring you all the columns, all the data that meets those conditions. And if their first 3 letters is LIS getting pulled back. Now that'll filter down the data set even smaller for you to be able to say, oh, okay, this is what I'm looking for. Because if we say where first name like LIS and last name equals, RLB, spell your name, it'll pull back exactly who you need.
Okay, gotcha.
Yep. That's filtering, and that is also a real life example of like those string functions.
Okay.
You on the road today, girl.
There's so much that I was like trying to gather from all the last coding challenges, because I would get stuck and try to make up my own codes. I don't know. I end up figuring it out, but it's like I had so many small little questions I just needed clarified. That's
yes. All. And I love it because that helps, that's what you need to do. Like it takes it, and the way that my brain works is it makes it real. It makes it like you can apply it to what you already know. And when I can apply something to what I already know, it's good, especially if I'm already good at it. Like if it's something that like I know like the back of my hand, baby.
Absolutely.
So that's exactly right. That's exactly right. But yeah, that is where, but that is another form of how you can use a string function as well. And if you want to hop in here one day this week or whatever and look up like use like, say where this column, like this, and you can see exactly what I'm talking about. But yeah, so write down your note, and you more than welcome to, because that's a it's a valuable asset too. But yeah. Any questions? Carla, you good?
I'm just trying to absorb everything in.
Okay.
I'll catch on eventually.
Okie doke. So I'm looking at my data and it's taking our data load. So we're actually going to go in our orders DB. And I will give y'all the use case as soon as this. Because I'm trying to see what the exact column is. Because I don't want to tell y'all the table, but I know what table is in. Oh, wait. It's still loaded. Okay, here we go. Okay. So we're in the orders DB, but bring me the order detail. I'll type it in the chat and I'll say it out loud so they can have it on the recording. Okay. Provide me with the order detail ID, all those columns, and I did not mean to put 2 commas. Provide me with all of those columns where the total price is greater than the average. So your first thing you need to do, data investigation, which table answers this question. Select your top 1,000 rows and build out your query based on the use case. It's going to require you to do a subquery, but build it out based on the use case. And I'm going to do it with y'all as well on mine. What did I say? Total price. And am I on mute? No, I'm not. Okay. And if y'all want to talk through it, just talk through it. You don't have to wait till you get all the way to the end or either just try to figure it out on your own. Also, remember to document your code too. Like, tell what you're doing in your code. How y'all doing?
I think I have it.
Okay. You want to share your screen? And yep, you do. And yeah, you documented your code exactly right. Unit price and total price where the total price is greater than average. Okay, documentation. Where total price is greater than the select average from the order you design. Okay, how you feel about that? Do you feel like that makes sense?
Yes.
Now,
yeah, I do feel like it makes sense.
Do you see? Can you walk me through like what your code is doing?
Right. So you asked to provide with the order detail ID, product ID, quantity, unit price, and total price.
Mm-hmm.
So I made sure the select statement had all of those columns involved in it.
Mm-hmm.
Took it from the DBO that provided all of the columns that we were looking for. And then when you ask for the total price, where the total price is greater, I asked for the total price with the greater, and then I separated where the average total price from that order table would be.
Absolutely. Now, if you was to get another ask and they were like, but bring me where the order is, greater than average and the unit price is between like $500 or $800, how would you put that in your code?
I would think I would put the and statement behind this last parenthesis here. I guess, hold on. And I don't know. Wait a minute. Should I add a?
No, that's right.
Because it came up gray.
That's right. Take your and put it on line 12 just to keep it like.
Keep it.
Yeah.
Okay.
And make it uppercase too. But absolutely, and let me share my logical operator screen with you. I think I got it up. You would actually use your between one, but that's exactly right. Where are we? Oh, here we go. Where whatever column between whatever your values are, but that's exactly right.
Okay.
Yes, ma'am. Yep.
And can that go on based on what the use case is asking for?
Absolutely. So let me see your screen. You got where, and you say and unit price between whatever the ask is. And then if you want to say and quantity is greater than 5, you would put that. And total price is greater than, you would just keep building your code on top of it.
Okay. Oh, so it could be several lines long.
Yes.
Okay.
Do between, not equals, because we're going to do between. Do between 500 and 800. Yep.
Between, how is this written?
That's right.
500 dot.
Yep, and 800. Not execute.
Oh, wait.
Perfect.
Okay.
Perfect. Let's say you got a unit price between. Now let's say, and a quantity is greater than 3. What would you do with it?
Would I put and again?
Yes.
Put the quantity?
Yes.
And quantity is a column.
Yep.
So I would have to type it out the way it is.
Yep.
It would be greater than. Should it be a 2-digit column or like 0, 3?
It's the 3. There you go. Not execute.
Okay. That's nice filtering here.
Period. You got a whole lot going on. You got your subquery on line 11. You actually have a lot going on. You got your subquery on line 11 where that where statement started your condition. That's the first condition right there. Because remember, subquery is a condition where total price, that column, is greater than average total price from the order details table all day long. Then he came down and said, and unit price between 500 and 800. That's the logical operator. And quantity is greater than 3. Like, you are right. You're building your code based on what is the need.
Okay. I was thinking my brain is just telling me sometimes after the and statement, after the 800, I would put a comma.
Right.
For some reason.
Because that's how we
execute.
Yeah.
Okay.
That's just how our brains, and we have to like unlearn it in a way.
Are the columns, I mean, not the columns, are the commas specifically for the columns only?
That's it. But you can use it you can in an end. Like if you say have the logical operator in, like, can you see where here it is?
Yeah.
Oh, here it is right here. In, and I list out all the values from that column. Then I would list it out. But like other than that, no.
Okay.
Nope.
Good to know.
Nope. You and or between.
Okay. Thank you.
You're welcome. Carla, how you doing?
I'm doing okay. It's just the commas issue that I'm running into, but I see where I made the mistake.
Okay. You feel okay about your subqueries? You want to share your screen and talk through something? Or are you good?
I'm okay, thank you.
Okay. Case statements. So case statements go into what we call, it's essentially a condition tool as well. Because case statements essentially categorize your data based on certain conditions. That's what it does. If this condition is met, then we're going to call it this. If this condition is met, then we're going to call it that. It gets into like that if, then, else type thing. You'll also see like that type of logic applied in Python, because Python has what we call loops. If this condition is met, then this. If this, then this. Like, it's essentially that whole type of criteria. I'm going to call it this. If this is what the condition is, then it's this. Think about it in your day-to-day healthcare. Somebody comes in and their labs brings them and they get a certain amount on their labs or whatever. They might be considered high risk. They might be considered this, just based on the labs now. That's where you would use like those conditions. If this condition is met, then we're going to call it this. If, then. You just keep writing your code. If, then, if, then, if, then. This syntax here, select this column, this column. See our comma here, because our case statement is going to create its own column. Comma, case. We start our case statement, case, when this column is greater than or equal to 90, then it's an A. When this column greater than or equal to 80, then B. When this column greater than or equal to 70, then C. Else. If it doesn't fit any of this criteria, it's an if. End as grade. End it as this column name. This is our column name, grade. So we're essentially adding a whole new column to our output from the students table. Case statements create new columns based on categories and conditions. Any questions about a case statement? Okay. So for this one, let's go. Okay. So for this one, we're in our medical. For this one, we're in our healthcare system database. So I'm gonna give you the use case, and once I give you the use case, the first thing you have to do is data investigation. Which tables answers this? So I'm gonna give you the use case. Oh, okay. I'm tripping. That's why I like to write the code. Okay. Okay. So if the test result is severe, it's a severe issue, then label the patient as high risk, abnormal, medium risk, mild issue, low risk, normal, no risk. Anything else should be labeled as not tested, and name the new column risk assessment. Also for this, bring all the columns over in that from that table that you're going to use. So just bring all the data over, but include your case statement in it. And I'm going to write it with y'all. Okay. Mild issue. Normal. No risk. Y'all good? No rush. I'm just checking on y'all. Can y'all hear me on here on TikTok? Hey, I'm a vibe. Can you hear me? Can you hear me? Can y'all hear me? Okay, bye. What does it sound like? They can't hear me.
I did this, but it's like I'm getting error messages.
Let's see. Oh, I'm on mute. Let's see. Let's see what you're talking about.
You can hear me?
Mm-hmm.
My volume went down.
I'm going to stop sharing so we can look at your code. And I'm going to actually put y'all on a big screen so I can see. Okay. So, girl, get rid of that. Okay. I instantly can look at it. You're going to get to the point where you're going to instantly look at it too. Your code is right. The problem is not even like a real problem. Get rid of your comma in front. As a matter of fact, keep all the columns anyway. Keep them in there. Get rid of all that commented out. But your problem is, you see on line 9, you have that comma in front of result. It's technically not a column in front of there. So get rid of that.
This little comma?
Yes. Let's test it.
Why though? I thought we needed that.
What's in front of result?
That?
No, case. Okay, so, and another thing, case. Your case starts it out. So get rid of line 9. Get rid of result on line 9.
Take result out?
Yep, because
I thought we needed that.
You got it. You got it on line 11, 12, 13, 14. You do need it.
Okay. So we don't need that there.
No.
Or should I just put the line?
Oh, well, yeah. Now execute. Okay, so it's saying incorrect. Oh, now in as risk assessment, you can't have like spaces between stuff. So you can either make it one word or either like a little underscore in between on line 16.
And as
risk assessment.
Should be one word, really.
Yep. Now execute.
Really? It'd be the smallest thing.
It is.
Now, I would have sat here for an hour if I didn't have you on the call.
Now go up and let's actually include all of your other data. So now you do need columns. The problem was you were trying to say on line 9 you had result. The way your brain conceptualized it is you're trying to pull a result in. That's what you said in your head. But which is correct. Ain't nothing wrong with it. But on line 11, 12, 13, and 14, that's what it's doing.
So it's pulling it anyway.
Yep.
So we can't really pull it twice.
That's you can say, yeah, you actually can. So put a comma in front of case.
A comma?
Yep. Now let's uncomment out all of your other code that you got up there.
Like these?
Yep. And let's pull all the data over. There you go.
All of them?
Yep. Yep. Now let's put a comma in front of result. Yep. You need a comma there. Now execute. And there you go.
So that comma in front of case is what helped me bring the other columns in?
Yep. We treat our case statement like a comma because that's what we're doing. We're ending it as risk assessment. On line 16, end as risk assessment. That's your comma. That's your new column. So that case, all between line 10 and 16, that's a column, quote unquote.
So we just created a column.
Yeah.
To give us the data that we're specifically looking for.
Yes. We created a column to give us exactly what we need based on conditions. When result equals severe issue, then high risk. When result equals abnormal, then we create our own column. But that column, the logic of that column is based on conditions.
Right.
That's exactly.
Is it better to keep all the other columns up here, like the test ID, patient ID? Because the first time I blocked them all out.
Yeah.
But that wouldn't really give them a valuable source of information to look from.
Right.
Okay.
That's exactly.
Because if the other department is looking at it, they would say, well, what's all this risk assessment?
Right. What was the test?
Right.
Yep.
I'm creating an easy table for them to look
at.
Okay.
Yep. That case statement creates its own column all day long based on the logic that you provided. When this column equals this, then high risk. When abnormal equals this, then that. You can bring the actual data from result as well, but that's a different column from your case statement because you brought over result and you brought over risk assessment because technically you created a new column based on the data that's in that column, based on the data that's in result. But you brought over a whole new column.
Okay, got you.
That is a case statement. When this condition is met, let's call it this. I know what that is, but I need to call it that for my data set. Let's say you have a range of numbers that's presented to you. It makes more sense to look at my data categorized like this than a range of numbers. Tell me if this patient high risk or not. So.
Right. Okay.
But yep, this is a case statement, and that case statement falls into that. It's a condition. It's the conditional logic as well. It's just a different way to apply it, and it helps make your data more readable. It helps make your data more digestible. It makes it cleaner, And it's also, like you said, important to bring over all of those columns so you can have something to compare it to. Now, if I was to say, I only want people who took a cholesterol test, how would you capture that?
The people with the cholesterol test, I guess I would give them the patient ID and test name.
What's another way? I want everybody that took a cholesterol test categorized.
Using this same type of case statement?
I don't need no case statement.
Oh, okay. Then I have to look at my notes.
Filter. Where
Statement.
Yes.
Okay.
Where
the test name equals
yes.
cholesterol.
Yes.
Okay.
Yep. So if I say where test name equals cholesterol test, because that's how it is down now, I'll do it just like how. Oh, I'm still seeing your screen, but I will still say where test name equals cholesterol test, and it'll only bring me back what I need.
Okay. So you would add that on, right? Yep. Okay.
Think about it like when you build your code, that's why it's important to get those good foundational understanding. Because once you get your foundational understanding, everything we do literally builds on that. All the logic, everything is building. Everything. You get a good grip on like what's the foundation, how to apply it, how to think through it, what do I need to look for. Everything else, you got that. Anything else you want to add on there? Where this condition is this, and risk assessment high risk, and test date in the month of December, and whatever. You can do whatever you want. But yep, that is the case statement. If, then, else. Break down your data based on those certain conditions. And your logic, the way you did that, when, it's just gonna keep stacking it. I ran stored procedure with 600 lines of code, 800 lines of code, 1,000 lines of code. And it's literally like you go and you build it. Select your table and literally like build what you need piece by piece. And you're going to be good every time. Every time. Carly, you got any questions?
No, it's just the commas, just remembering to include them.
Oh, in the like when you put your case start your case.
Yes.
Yep. And I really like when y'all be having ears like that. Like, baby, get that comma out your code and let's go. I love those type of errors because it always shows like, I'm good. It's just a little razzle dazzle stuff. So this is the start of the show, y'all. Case statements and joins was the start of the show. So let's get into joins. This is like my favorite thing. It used to be my least favorite thing. And when I would do technical assessments, if I had to do a join, I would be like, I'm about to go. There's no point in either one of us sitting here. But now I'm good. So let's get into join. So it's not uncommon when you have to do your analysis to pull data from multiple tables. In a real life system, your data is distributed everywhere. Everywhere. I can't stress that enough. And as the analytic professional, you're supposed to be the expert of it. So you're supposed to be the one that someone can come to and just, get the data. I have this request. People at HR don't know where the data is housed. People at HR don't care. It's not their job. So it's you as an analytic professional, you're supposed to come through and say, oh, okay, let me do my data investigation and figure out which tables has this data. What's the common field? How to join it? How to do, what do I need to join it on? Et cetera, et cetera. That is your job. However, in order to do that, you will literally have to join tables. And in SQL, when you refer to something as a join, you essentially are combining rows from multiple tables. And you combine those tables based on the related data that's between both of those tables. That's why I stress to y'all the importance of data investigation. Go and look at your data. Go and actually literally look at your data and tell me what the relationships are, what those dependencies are, because that skill is going to leverage you with joining your tables. So with that being said, there are 4 types of joins within SQL. You got your left join, your right join, your outer join, and your inner join. And it is not uncommon within technical assessments for somebody to like ask you what are the different types of joins. So please have like something like this handy, just so you can look at it. So we're going to start out with the left join. What a left join does is it brings all the data from the left table and common data from the right table. Your left table and right table, it ain't got nothing to do with how the data is in the database, any of that. It's literally how you format your code. What's to the left of your join syntax? What's to the right of your join syntax? So your left join, all the data from your left table, common data from your right table. Inner join. When I say an inner join, my inner join only brings back common data from both of my tables. Your left join and your inner join are going to be your bread and butter. That's going to be what you do on your day-to-day life. And why? Because the way that we are naturally taught to write things, when I'm writing left to right. Left to right. So if I want something from a table, I'm going to naturally just list that table first. However, the same way we were talking about like the delete statements and the insert statements, you need to know them because like they ask it. So we got our left join and our inner join. Also within an inner join, it's highly possible to eliminate pertinent data as well, because with inner joins, you only bring back common data. If that data is not common in both of those tables, it is not returned in your output. If it's not common, it ain't coming. So does not return. Right join. All your data from your right table, common data from your left table. Full outer join. Bring me all the data from both of these tables. I don't care if it matches or not. I don't care. Now, full outer joins are also extremely uncommon because typically when someone is trying to join multiple tables, they're doing it with the purpose of doing some sort of analysis on this data set. The full outer join doesn't discriminate, so it's going to pull all your data. I don't really need all my data, first of all. Secondly, it's what is called an expensive query. It can block other queries from running in your database if you're in an organization. So if you run it, you might, DBAs and stuff might be like, what's she over there doing? Most common, left and inner. But please just know all of them. At least be able to know how to explain all of those. I had like the join syntax written on a whiteboard in my office for like years. Literal years. Because I needed to see these syntax. I had to see it. Also, the way a good way to do it is like just always explain it. Like even when I'm on interviews or whatever, I explain it like with my hands using like the Venn diagram. Left join returns all the data from the left table, common data from the right. Inner join, only common data. Right join, all the data from the right table, common data from the left. Full outer join, everything. Any questions? So let's get into this syntax. Okay, so this is our inner join syntax. So remember what I was telling y'all, how everything we do or have done is nothing. We're literally building. We built the foundation, and now we literally are building more advanced concepts on top of the existing concepts. What do you already know? What have we already learned? Now let's just keep adding to that. Select E dot name, D dot department name. What is this E dot? Why is this even here? What is this even talking about? This is an alias. What this is saying is, you see we have our from statement here, from the employees table, space E. I basically named this employees table E. So when I'm pulling my columns, you don't have to, but you can specify which tables you're pulling your columns from. E dot name, give me the name column from the employees table is all that is doing. Now, let's say that you have two tables and they both have a common column. Then you have to specify the name of your column. Or the source of your column, rather. So select. We selecting E dot name, D dot department name. The department name from the department table. That's it. Select these columns from this table, inner join this table on E dot department ID, join it on the department ID from the employees table and the department ID from the departments table, because that is the common column between both of those tables. That's why when you're doing your data investigation, you expand your data, you expand your tables, you go and look at them columns, you're like, oh, okay, this is the common column. This is why you need to do that. Data relationships are everything, not just within SQL, but within Excel, within Power BI, within everything. Like your data relationships is literally your bread and butter, because it helps you create the relationships and the dependencies between multiple tables. And in order to create those relationships and dependencies, you got to do your investigation. Here we have our employees table. We got our employee ID, our name, and our department ID. Here we have our department table. We got our department ID and our department name. Here we have our output, or the result. What is eliminated from our output, and why do you think it is eliminated? Why is it eliminated?
I see the employee ID is eliminated.
Mm-hmm.
I don't see the syntax asking for it.
Bingo. So that's why that employee ID is not in there, because we didn't ask for it. Now, what data is not included within our results set and why? Look at okay, so we pulled a name. Look at our names and see what it pulled over. Look at our department. We pulled over department names. Look at our department name and see what it didn't pull over. And why do you think it was eliminated? Oh, and remember that an inner join only brings back common data. So if it only brings back common data, then that data has to exist in both tables to come in our output. Do we have sales in our output? Sips tea.
Would it not show you the department ID because it's like, wouldn't that be confusing if you combine both of it?
Well, we didn't pull it. We in our select statement, we pulled the name and the department name. So that's what we got right here, name, department name. But when you look at the actual data in the department name, we got HR and IT. But in our departments table, we also have sales as well. Now, within our output, we don't have any data for sales in our output. We don't have anything for sales because sales only exists in this department table and it does not exist in this employees table.
So we only pull in common.
Yes.
Data. And if it has something different, we're not pulling that.
Exactly. That inner join only brings common data. If that data does not exist within both of those tables, it's not going to show up in our output.
So even though with the inner join, it does say departments.
Correct.
That's just like an underlying thing that it's just going to know not to pull something that's outside of that data that doesn't match.
Correct. Because we specify inner join. And when I specify inner join, I say select this column from this table, inner join this table on department ID equals department ID. Pull this data from these two tables, but that inner join only brings back common data. That data has to exist in both of those tables. Now
and that's the rule of the inner join.
Yes, that is the bare minimum. That's what it does. Now,
I'm just a little confused by the alias.
Okay.
The E, the D, D dot, E dot. That's what it's like. Are we creating that alias?
Yep.
So we can understand it when we pull it?
Yep. Your alias can be whatever you want it to be. I've seen people write A, B, C, and they have A for person.
I was going to say that. Could it be like, in my mind, it would be like table 1, table 2.
It can be whatever you want it to be. It's literally yours. It can be.
Okay, I can see it on. When you go to on, I can see how you have E department ID and then D department ID.
Yep.
Okay.
Think about like when I say on, you say on. When I say on, I love to hear people. Yeah, I love to hear people accent. When I say on, I'm saying on this column, on that column, stack them on top of each other. Where's the match? Where the match at? Where's the match? That's literally it. And I'm saying E dot, I'm saying the department ID from the E table. But whatever you feel comfortable naming your table, if you want to name your table 1, 2, 3, if you want to name your table A, if you want to name your table B, you're more than welcome to. Whatever makes sense for you. And that's why it's important to like know how to apply and not, that's why application trumps memorization. Because how you write your code, it don't matter. How I write it could be 2 totally different things. What's the output? What's the goal? But that's absolutely correct. That alias can be whatever you want it to be. I've seen some people go in ABC order where they say table, where they say table, this table is A, this table is B, the next table is C, the next table is D. I've seen it all kind of ways. So whatever way that your brain works to help you to be able, like you say, to identify that table, be your guest. As long as you know that that table is this table, or that alias refers to this table.
Because it could be, so what you're saying, like with from employees E, that could be the left table.
It is the left table. It is.
The left table.
In your left joint, that's exactly what it is.
So there's an employees section in both of them, really, both of the tables. So we're just labeling which one is which.
Yes.
Okay, I just try to wrap my mind around that.
Yep.
Okay.
Now this the inner joint. Now this the left joint. Select E.name, D.department name from employees table, left join. Left join. So if I say left join brings all the data from my left table. This is my left table. My employees is my left table because it's the table to the left of my join statement. So it's going to bring all my data from the employees table, regardless on if it's a match or not.
Regardless if it's a match or not.
Yep. If it's not a match, it's going to bring the data, but it's going to say null like this. Here we have we have our E.name, the name, D.department name from the employees table, left join departments table. So that would make our employees table our left table because it's the table to the left of our join statement. So if I say left join, then left join brings all the data in the left table, regardless on if it's a match or not. It don't care nothing about a match. Give me the data from this table. Give me the data from that left table. Give me all that data from that left table.
And the inner one was when everything basically matches. It's just going to filter out what doesn't.
Yep.
We won't even get a no. It just won't show it.
Bingo.
Okay.
Inner join, that Venn diagram, this is the inner join. Only matching.
Okay.
If it's not common, it is not coming.
Okay. Yep. That makes sense.
Left join, all the data from the left table, matching data from the right. Only give me the matches. If it doesn't match, leave it over there.
Gotcha.
Or I don't say leave it over there. If it doesn't match, give me the data, but don't populate it. Right. Yep. Left join, data to the left, table to the left of my join statement. This is my join statement. This is my left table all day long. All day long. Give me all the data from the table. Give me everything. I want all the employees, whether they made an order or not. I want all the employees, I want everything from their table. That's my base table. I need all that data. Right join is the same thing. It's the same thing. The only thing we doing is saying right join. And when I say right join, I mean all my data from my right table. This is my right table. It's the table to the right of my join statement. Only matching data from my left. On common fields. Your syntax literally never changes. The only thing you change is inner, right, left. But your layout literally never changes. Your conditions literally never change. You can say where department ID is 1. You can put all your logic right under here. Full outer join. Full outer join returns all the data, whether it's a match or not. It does not care. It does not care. Bring me back all the data from both tables. If there's not a match, just bring a null over here. But give me all the data from both of those tables, though. You won't hardly ever use it. But know it. You ain't gonna use it, but you need to know it, though, because like people gonna ask it. Any questions? Now, your case statements, your subqueries, your logical operators, your conditions, your aggregate functions, all of that can still fall right into your select statement like normal. We're building, just because we join in tables does not mean we will not use everything else that we learned. It just means now that we know how to join those tables. Any questions? Your where, when you filter out your data, it's going to always go after your own statement. Same concept. I need all my data first, and then I'm about to filter this data. This gives me all my data. Let's say you have multiple joins. Select from this table, join this table on these columns. Put another join statement. Join this table on these columns. Join this table on these columns. You just keep joining. Same layout all day long. Any questions? Let's go there. We are gonna go. Let's use our healthcare system database again. I'm gonna type the use case in the chat, and then I'm gonna say it out loud so y'all got it on the recording. Carly, you good?
I think I'm okay. I'm not sure.
Okay. Anything? Okay. Anything in particular you wanna talk about?
No.
Okay. Okay. So bring me the first name, patient first name rather. Patient first name, patient last name, date of birth, gender, phone, email, test name, test date, and result. First things first, data investigation. Which tables answers this question? Once you get to the table, select your top 1,000 rows and build your syntax on that. Also, this will require, I want all the patients, regardless on if they have a test or not. So data investigation, select your top 1,000 rows. And I'm gonna do it with y'all. What I do, what y'all do it. Patient. Testing.